Here we want to locate the discontinuities of the function and illustrate by graphing y, which is equal to the natural log of tangent squared x. So before we do that, okay, let's go ahead and plug in our function. So we have the natural log of the tangent squared x. Okay, so what we want to do is we want to at least see what's happening here in terms of our increments of pi. So we need to come over here and take a look at our settings. Okay, and so what we can do is we can go from, let's say, negative 2 pi. So negative 2, type in the word pi. And then over here, we're going to go and then put in 2 and then pi as well. Okay, and then the step in the increments. So let's do this in increments of pi over 2 so we can see what's happening. Okay, and then maybe let's go from negative 6 to positive 6. So it's important to be able to figure out what our settings of our viewing rectangle is when we view this particular problem. So I'm just going to scroll up here a little bit and let me take a picture. So here is our graph. Okay, so now we need to figure out where is it undefined. Well, you can see here that it's undefined at these particular values because it's going here and it's going there, but it's never touching. Same thing over here. So what values on the x-axis does that represent? Well, if we take a look at those values, we can see that at the line of x, which is equal to negative 5 pi over 2, that is an asymptote. Okay, same thing at negative 3 pi over 2. Same thing at negative pi over 2, 3 pi over 2, and 5 pi over 2. So therefore, if this is an asymptote, that means it is discontinuous at those particular points. In addition to these points, we can also see that 0 is also an asymptote. So let's first take a look at the function y, which is equal to the tangent squared x. And this is discontinuous from or at the values where x is equal to pi over 2 plus pi k, where k any integer. So when k is any integer. Okay, next, what do we know? We also notice that on this function y is equal to the tangent squared x is discontinuous at 0. So that means that when this is going to be x, which is equal to 0 plus pi over k, that means when x is equal to pi k, and k is any integer. So therefore, if we look at our particular values here where we can see those asymptotes, and where it's discontinuous, we can say that the function y, which is equal to the natural log of tangent squared x, is discontinuous at x, which is equal to pi over 2n, where n is any integer. And again, you can verify that over here.